So the fourth point is topography, and if we want to classify the topographical factors, then topography has been divided into four types based on the cross slope. Okay, so for the plane this is 0 to 10%. Okay, for the rolling terrain this is 10 to 25%. For the mountainous terrain this is 25 to 60%, and for the steep terrain this is 60%. Likewise, if like this is the 0%, then this is for the plain terrain, and this is rolling terrain. Okay, this is mountainous terrain, and this is steep terrain. So this is 0 to 10, and this is 0 to 10%, this is 10 to 25, this is 25 to 60, and this is greater than 60%. Okay, remember, if cross slope is large, then simultaneously there will be increase in the curvature of the road, and that would lead to the increase in construction cost. Okay, now talking about the fifth parameter, that is design speed, and this is the basic parameter which determines the remaining geometrical features. Okay, likewise, if you want to calculate the stopping side distance, we want to calculate the overtaking side distance, we want to calculate the length of the transition curve, we want to calculate the super elevation, then in all those calculation, or all those calculation of all those geometrical parameters or geometrical design parameters, the basic requirement, or you can say like the basic parameter would be the design speed. Okay, though IRC has recommended certain values for the plain terrain, rolling terrain, and mountainous terrain and steep terrain, though you don't have to remember all the table, but you have to definitely remember some of the values, and some of the values are quite important. And if likewise, as you know, this the chapter is, in the name of the chapter is the design, or you can say like the geometric design of highway. So basically it deals with the design of the highway. Okay, so if let us say, if in a question it is being given that design a highway according to the IRC recommendation. Okay, and if you don't know the values, then let us say if they have been, it has been asked to design a national highway, then no speed recommendation is given, or no speed data is given in the question, then in there has been mentioned that you have to follow up the IRC recommendation. Then what does the IRC recommends, or what are the recommended values by IRC? That is, for the plain terrain, and the ruling design speed is 100 km per hour, and the minimum design speed is 80 km per hour, whereas for the rolling it is 80/65, for the mountainous this is 50/40. But you have to just remember the values for the plain terrain, but mostly these two values are asked in the examination. That is, for the NH and state highways, the ruling design speed is 100 km per hour, whereas the minimum design speed is 80 km per hour. However, in some of the exams, the speeds of the urban roads are also been asked. Like if you talk about the classification of urban roads, then for the arterial roads the recommended speed is 80 km per hour. For the sub arterial this is 60 km per hour. For the collector streets these are the 50 km per hour, and for the local streets this is 30 km per hour. Okay, and for the expressways the recommended speed is 120 km per hour. Okay, so these are the speed recommendation, or you can select the design speeds as recommended by the IRC. Okay, now talking about the various elements of the geometric design which we need to cover in this module 2, then there are cross sectional elements, side distance elements, horizontal alignment distance, vertical alignment details, and the intersection facilities. Okay, so these four are quite common, and many times question have been asked in from this particular topics. Okay, now covering up the cross sectional elements. Under the cross sectional elements we will be first studying about the pavement surface characteristics. Okay, so under the pavement surface characteristics we talk about the friction. Okay, as you already know what friction is, we do not need to cover up the in that much of detail. So basically what you need to know about the two term, that is skid and slip. Okay, so what is this skid? When the path traveled along the road is more than the circumferential movement of the wheels due to friction. Let us say if a wheel is there, and if there is a circumferential movement, okay, and the path traveled along this particular road is more. Okay, if this is more, let us say if this is A and this is B, okay, this moment, then can we say like if A is greater than B, then there is a possibility of skid. Whereas for the slip, when the wheel revolves more than the corresponding longitudinal movement along the road. Okay, so let us say instead of going far distance, when it revolves more than this particular distance, then you can say that is the case of slip. So for the skid, that is the path traveled along the road is more than the circumferential movement, whereas for the slip, the wheel revolves more than the corresponding longitudinal movement along the road. Okay, you need to remember this relationship. This is quite important, that is friction is inversely proportional to temperature, inversely proportional to tire pressure, and inversely proportional to load. Okay, now talking about the friction, then friction have been divided into two types, that is the coefficient of longitudinal friction. Okay, and second is coefficient of lateral friction. Okay, if we talk about the coefficient of longitudinal friction, then IRC recommends the coefficient of longitudinal friction in the range of 0.35 to 0.40, whereas the coefficient of lateral friction is recommended as 0.15. These two values are very important because these two values will be utilized in solving the numericals of super elevation. Okay, numericals of stopping side distance. Okay, so these values are quite important, and many times the direct values have been asked in the competitive examinations. Okay, now talking about the second cross sectional element, that is unevenness. Basically it measures the it measures how smooth the road surface is. Okay, let us say if this is a road surface and there are various dips and ups in this particular road surface, then it measures the road profile, or it measures the smoothness of the road surface. So what does the unevenness indicates? That is it is the cumulative measure of the vertical undulation of the pavement surface recorded per unit horizontal length of the road. Okay, so what are the ups and downs in a particular stretch of road, and these are counted, and these are counted cumulatively for a particular, or you can say like for a unit length of road. So let us say for a 1 kilometer road of length, what we have got, that there are certain recommendation. Let us say if 1500 per kilometer are the total cumulative undulation, then these are considered to be good, whereas if it's less than 25 then this they may be considered as a satisfactory up to a design speed of 100 km/h, whereas if the values goes beyond 3200 per kilometer, then this is considered to be uncomfortable. Okay, and this pavement unevenness is measured by the instrument, or you can say like the machine, which is called as the bump integrator, which measures the cumulative measure of vertical undulations. Okay, now talking about the light reflecting characteristics, white roads have good visibility at night, but they cause glare during daytime. If we talk about the white roads, what are the white roads? They are the CC roads, or the cement concrete roads, or the rigid pavements. Okay, so they offer good visibility at night, whereas when during the day travel, they causes glare to our eyes. Okay, if we talk about the black roads means that is bituminous road. Okay, or you can say like black top roads are sometimes also called. Okay, so they have no glare during the day. During the daytime it is clearly visible, however during the night conditions, when the surface is wet, then it poses several problems to the road users in visibility. Okay, concrete roads have better visibility and less glare. Okay, now talking about the next important cross-sectional element, that is camber or crossfall. So what is camber or crossfall? This is basically, camber is to raise the middle of the road surface. What is camber? To raise middle of the road surface in order to drain off the rainwater from the road surface. Let us say uh, if rain is falling on this road surface, then it will get drained out through the sides. Okay, so that is the purpose of providing camber, that rain should not be stored over a particular area, otherwise it would deteriorate the road surface. Okay, so camber is provided in the transverse direction. There are three types of camber. One is parabolic camber, second is straight camber, third is combination of camber. If you want to talk about the equations for the parabolic camber, then this is y is equals to 2x square upon n upon w, whereas w is the width of the road and n is the slope. Okay, second, for the straight camber, this is w upon 2n, and Third is the combination of parabolic as well as straight camber. Okay. For the parabolic or elliptical shape is preferred by the fast moving vehicles. Many times this question have been asked in the exam. Whereas when very flat slope is provided in cement concrete pavements, straight line shape of camber may be provided. And very important IRC recommendation, that is the cross slope for shoulder should be 0.5% steeper than the cross slope of adjoining pavement, सब्जेक्टेड टू मिनिमम ऑफ 3%. ओके, सो जो कैम्बर का स्लोप होगा उससे 0.5% जो है और ज़्यादा स्टीपर स्लोप हम लोग रख सकते हैं शोल्डर के लिए. व्हाट इज शोल्डर? शोल्डर इज द एडजेसेंट area. Let us say if this is the two lane road, this is 3.5 meter, this is 3.5 meter, and if there is a extra area uh, which is, you can say, like the width is usually 1.2 meter to 3 meter, though it is recommended that at least 1.5 meter is there, but on a rough scale it is usually 1.2 or 1.3 meter. Okay, and that shoulder can be used for any purpose, like parking the vehicle or parking in case if any vehicle is, you can say, like having some sort of problems, manufacturing defects. Okay, they need repair, or if any accident is there, so people can use that particular space for the emergency or recreational purposes. Okay, now talking about the camber recommendation by the IRC, then IRC recommends, as we know, this camber is basically provided to drain off the rainwater. Okay, so this camber have been divided or in for the four types of road surfaces considering the rainfall condition, that is for the heavy rainfall and for the light rainfall. These are the data which have been recommended by the IRC, and this table is quite important. Many times this direct values have been asked in from this table. Okay, for the cement concrete pavements and the high bituminous surface, this is 100. If you will remember the first 2 3 values, then you will get to know about the symmetry. You just need to remember the sequence of road surfaces. For the cement concrete and high bituminous surface, thin bituminous surface, WBM or gravel pavement, and the earthen roads. Okay, so you can see like this, there is data 1 in 50, 1 in 60. So this data has been repeated here, this data has been repeated here, this data has been repeated here. So 1 in 50, 1 in 60, 1 in 40, 1 in 50, 1 in 33, 1 in 40, 1 in 25, 1 in 33. Okay, so this table is quite important, and many a times question is being asked in from this particular table. Okay, now let's talk about the next parameter, that is width of carriageway. What is width of carriageway? Width of carriageway is basically depends upon the width of the vehicle plus the clearance distance. Let us say for the two lane pavement, okay, let us say this is vehicle number 1 and this is vehicle number 2. Okay, this is vehicle number 1, this is vehicle number 2. So if we consider it as 2.5 meter, we consider it as 2.5 meter. Okay, and we consider the spacing between this particular vehicle as 1 meter, and we consider it as 0.5 meter. The side clearance is 0.5 meter. Then if you look at the total summation, this is 0.5, 2.5, 3 meter, 4 meter, 6.5 and 0.5 meter, that is 7 meter. Okay, so basically width of the carriageway is the total width which is available for the vehicle user to drive on particular pavement. Okay, so it depends, and this width of carriageway depends upon the width of the shoulder, width of the vehicle, this width of the vehicle and the clearance between the vehicles. Okay, the maximum permissible width of the vehicle as recommended by IRC is 2.44 meter. Okay, and the side clearance for single lane traffic is 0.68 meter. And this data is quite important, in the we have already covered 1 2 questions particularly on this, like the width of the pavement without raised curbs as recommended by IRC. Okay, so this is from this particular topic. Okay, so for the IRC recommends for the single lane, the width of the carriageway should be 3.75 meter. For the two lane with no curbs, this is 7 meter. With the two lane no curbs, 7 meter. And for the two lane with raised curbs, this is 7.5 meter. For the intermediate lane, this is 5.5 meter, and for the multi lane, this is 3.5 meter per lane. Okay, now next Talking about the next parameter, that is traffic separators or medians. Basically, traffic separators, the main purpose of traffic separator is to prevent the head-on collision between the vehicles coming in opposite directions. Let us say if a vehicle is coming from this side, if a vehicle is coming from and this side, if a single let us say if two-lane pavement is there, if there is no proper demarcation of the traffic, then there might be chances of the head-on collision. So that is the reason, in order to prevent the head-on collision, the concept of traffic separator or median have been introduced. Okay, there are certain recommendations for IRC which we need to keep in our mind, so that if question been asked from this particular recommendations of the traffic separators, then you can mark it on the question paper. Okay, so IRC recommends a minimum clearance desired width of 5 meter for median of rural highways, which may be reduced to 3 meter if land is restricted. For the long bridges, width of the median may be 1.2 meter to 1.5 meter, and the absolute minimum width of median in urban area is 1.2 meter, and the desirable minimum is 5 meter. Okay, what is important is 5 meter you need to remember, and 3 meter you need to remember. Okay, now talking about the shoulder. Okay, as we have already covered, shoulder is a road margin which is given to the side of the road, and the minimum width is recommended as 2.5 meter for the two-lane rural highways in India. Okay, now talking about the width of the formation and the roadway. Okay, what is the width of formation of the roadway? Basically, width of formation is the width of the pavement plus shoulder plus separator, if any. Let us say this is the uh, pavement, two-lane pavement, this is the shoulder. Okay, this is the shoulder, so this is the total width of the formation. Okay, so IRC recommends certain values for the plain and rolling terrain, for the mountainous and steep terrain. For the national highway and state highway, this value is 12 meter, that is the total length is 12 meter, whereas for the mountainous this is 6.25 meter, and for the double lane this is 8.8 meter in the case of mountainous and steep terrain. Whereas for the MDR roads, what does it stands for? MDR stands for major district roads, and the values recommended by IRC for the plain and rolling terrain is 9 meter. Okay, for the culverts having a span less than 6 meter, overall width is measured from outside to outside of the parapet walls. Okay, for the bridges having span greater than 6 meter, the width of the formation recommended by the for single lane bridge, this is 4.25 meter, whereas for the two lane bridge this is 7.5 meter, and for the multi lane bridge this is 3.5 meter per lane plus zero point 0.5 meter for each carriageway. Okay, and at causeways and submersible bridge the minimum width is 7.5 meter. Okay, you just need to remember this value because sometime this question is being asked from this particular data. Okay, now what is right of way? Right of way is the land required for the road along its alignment. Okay, so basically it talks about the land width which is being required for developing the particular, let us say, two lane road or four lane roads. Okay, so what does area does it require, what does width of the area it does it requires, does it needs to be considered for the future development, then accordingly the road width is considered. Okay, for the plain and rolling terrain and for the national highway and state highway, this is recommended by IRC as 45 meter for the open areas, whereas 30 meter for the built up areas, and in the case of mountainous and steep terrain this is 24 meter for the open areas. Okay, now let's talk about the these are the certain cross sectional elements which we have covered. Like if we go through this elements of geometric design, then the first subtopic was the cross sectional elements which we have already covered. Okay, like pavement surface characteristics, unevenness, light reflecting characteristics, camber or crossfall, and width of carriageway, width of formation, etc, etc. Now let's talk about this side distance element which we need to cover up. For this side distance element, basically we study major topics as overtaking side distance and the stopping side distance. Okay, so what are the side distance consideration? That is stopping side distance, it is also called as absolute minimum side distance or also called as the non-passing side distance. Whereas second is OSD, that is overtaking side distance. third is intermediate side distance, fourth is headlight side distance, fifth is safe side distance to enter into an intersection. But you need to just remember the first three, because question is being asked from this first three. However, ISD is considered as two times of stopping side distance. Okay. Now, while studying this side distance consideration, you need to remember some of the important time, like the average reaction time is considered as 2.5 seconds, and this is considered, and this is actually 90th percentile reaction time. Okay. Higher the speed, more time will it require to stop the vehicles. Hence, it can be considered as, if the speed is higher, then simultaneously the side distance will be higher. We will be getting this relationship along with the, you can say, like the formula. Along with the formula, we can also prove this particular relationship. Okay. For the safe geometric design, we assume that the vehicle may be achieve 50% of brake efficiency. Okay, so while we solve the numericals, we used to achieve that the brake have at least 50% of brake efficiency. Okay. For the positive gradient, side distance is considered less, whereas for the negative gradient, side distance will be more. However, we'll get to know this by the following formula. Okay. Now, talking about the stopping side distance, then a stopping side distance is divided into two particular parameters, that is lag distance and the braking distance. What is lag distance? Lag distance is the distance traveled during the reaction time. What is the distance traveled during the reaction time? This is the lag distance. And what is the braking distance? This is the distance traveled by the vehicle during the braking operation. Okay, so how do we relate? How do we bring the relation from the for the stopping side distance? Then this is the work done in stopping the vehicle is equal to the kinetic energy of the vehicle. So what is the work done? That is FWL. Okay, that is force into displacement. Okay, so FWL is equals to half into mv square. This is the expression for kinetic energy, and accordingly when we compare this two, we get to know about the wavelength L is equals to v square upon 2gf. Okay, so whereas the distance traveled during the reaction time, so this is simply the relationship of speed is equals to distance upon time. So for the time period t, the distance covered is speed into time. Okay, so can we say like this, the stopping side distance, the relationship, you can say the formula for the stopping side distance is vt plus v square, vt plus v square upon 2gf. Okay, so this is the expression when all the data are given in meter per second. Remember, very important, that you need to keep in mind that if a formula is, if you are remembering a particular formula, then definitely you must remember that likewise in this formula, if we are using v, then this should be in meter per second. Okay, if you want to convert this formula into kilometer per hour, then the same expression can be converted into 0.278 v into t plus v square 254 f. What is f over here? F is the coefficient of longitudinal friction, which we have already covered, that the coefficient IRC recommend the coefficient of longitudinal friction in the range of 0.35 to 0.40. Okay, though this varies according to the speed. Likewise, for the speed greater than 30 km per hour, the coefficient of friction is 0.40, whereas for the speed greater than 80, it is 0.35. Okay, so maximum values of coefficient of longitudinal friction is 0.40, whereas minimum value is 0.35. Okay, as the speed increases, you can say the coefficient of friction is decreases. Okay, as the speed is increases, the coefficient, as the speed is increasing, the coefficient of friction is decreasing. Okay, now when we introduce the concept of gradient in this particular stopping side distance concept, then this formula get remodified, and this comes at vt plus v square upon 2g f plus minus 0.01 into n. N is the gradient. Okay, that is in percentage. Okay, so for single lane roads, when two lane may movement of traffic is permitted, let us say if there is a single lane road, only single lane road is there, no, this is not there in the road. Okay, if a single lane is there and traffic movement is from the both direction, okay, on that particular stretch of road, okay, then in that case the minimum stopping side distance is considered as the twice the stopping side distance which we will be calculating. Okay, Next, what you need to remember, that is the height of the eye level of the driver is considered as 1.2 meter, whereas the height of the object on the ground is considered as 0.515 meter. This data is also very important, and this may be asked in the is very easy. These are the very easy questions, and it may be asked in the SSC type examinations. Okay, when the stopping side distance for a design speed is not available, let us say, as I already have recommended that if let us say in a question they stop, you can select the design speed is not given on a section, then speed may be restricted by the warning sign, and a suitable speed limit regulatory sign must be installed at a particular location. Okay, so let's go through a numerical so that you will get more clarity over the calculation of a stopping side distance. Okay, so let us say a question is there. Okay, that is, calculate the stopping side distance for a design speed of 50 kilometer per hour for a two-way traffic on a two-lane road. Okay, this is the question number one, and second is two-way traffic on a single lane road. On a single lane road. Okay, so what is the formula for SSD? This is the summation of lag distance Vt plus over braking distance, that is V square upon 2gf. But in this question the value of f is not given. Okay, let's say if f is not given, then we can consider the values according to the table, like for less than 30 this is 0.40, for 40, for 50, and simultaneously for 80 this is 0.35. Okay, so for the 50, let us say this is 0.37. Okay, so f is 0.37, coefficient of longitudinal friction is 0.37, and reaction time of driver is considered, average reaction time t is 2.5 seconds. So what is the speed? Let us say this formula is applicable when the data is given in meter per second. Okay, so we are not using the data in meter per second, so we are just using the formula 0.278 Vt plus V square upon 254 F. So this is the formula for the kilometer per hour. Okay, so this is 0.278 into V is 50 into what is T is the reaction time 2.5, plus this is 50 square upon 254 into 2.5. So when we calculate this value is coming to be 61.4 meter. Okay, so this is the stopping side distance which we found it as 61.4 meter. Now let's refer to the numerical. Okay, question which have been asked that is to calculate the stopping side distance for a two-way traffic on a two-lane road. So for the first case this answer is quite good, but for the second case, as we already covered that for the single lane road, when traffic is allowed from both the direction, okay, then in that case the minimum stopping side distance become the twice. In this case this is 61.4 meter, and for the single lane it becomes twice the stopping side distance. So our final answer would be 2 into 61.4, and this is 122.8 meter. Okay, now simultaneously question may be given when the concept of gradient may be involved, then in that case the formula may be revised as Vt plus V square upon 2gf plus minus 0.01 into n. Okay, in the question if the value of you can say like the value of gradient is given. Okay, now moving up to the second design side distance parameter, that is the overtaking side distance. Okay, so overtaking side distance is the minimum distance which is open to the vision of the driver before or who is intending to overtake a slow moving vehicle. Let us say a slow moving vehicle is moving ahead of the fast moving vehicle, and if he want to overtake this particular slow moving vehicle, then what are the minimum distances which is recommended so that he can comfortably or you can safely move, overtake and move in his particular lane. Okay, so this overtaking the side distance is divided into three parts. Okay, the first part is like this, that is this is first part d1, and this is second part this is sorry, this is second part, d2, and simultaneously the vehicle which is coming from the opposite direction, this is third part. Okay, so in the first part, the fast moving vehicle will move and come closer to the slow moving vehicle in order to find the opportunity to overtake smoothly. Okay, so in that particular time duration, the distance traveled is called as d1, whereas the total distance which is being traveled from here to here, this is called as d2, which have been divided into b plus 2s, and this is the total distance d3, which is for the opposite vehicle which is coming from the different direction. Okay, while he is going from here to here, then what is the distance traveled? This is called as the d3. So how do we calculate d1, d2, d3? So d1 is, let us say vb is the slow moving vehicle. Okay, so vb is the slow moving vehicle, whereas v is the design speed. Okay, so what distance that is covered is depends upon the speed of the slow moving vehicle. So let us say for the given time, let us say if you want, it is considered at the average reaction time under this overtaking side distance, because you want to overtake, the overtaking and the reaction time considered to be quite less, as bit less as compared to the average reaction time in the stopping side distance. Likewise, in the average reaction time in the stopping side distance was 2.5 seconds, whereas in the case of overtaking side distance, this average reaction time is considered to be 2 seconds. Okay, so what is the distance d1? D1 would be vb into t. Okay, now talking about the distance d2, then this is d2 will be b plus 2s. Okay, so what is b? This is vb into capital T plus 2s. What is capital T? Capital T is the time taken from moving the position from a2 to a3. How do we calculate this capital T? Then capital T is calculated by the relation, capital T is calculated by the relation 4s by a. What is a? A is the acceleration of the vehicle. Okay, and what is s? S is the minimum spacing between the vehicles. Okay, so s is the minimum spacing between the vehicles, and how IRC recommends a particular relationship for calculating the spacing. Then s is calculated, let us say if a speed is given in meter per second, then this is 0.7 vb plus 6, and for the speed, design speed, when the design speed is given in kilometer per hour, then this spacing is 0.2 vb plus 6. Okay, so our final expression for the overtaking side distance is vb into t. This is the speed of the slow moving vehicle. Vb into t plus vb into capital T plus 2s plus v into t. Okay, so this is the final expression for overtaking side distance. Okay, so let us say if vb is not given in the question, then what do we do? In that case, we can consider the vb, and that is the speed of the slow moving vehicle, as v minus 16. Let us say this is 80 kilometer per hour is given for the design speed. Then we need to know the speed of the slow moving vehicle, then we can take it as, we can consider it as 80 minus 16, that is 64 kilometer per hour. Okay, or if you want to convert it in meter per second, then this is v minus 4.5 meter per second. Okay, now if you want to calculate the overtaking side distance for the two-way traffic, let us say in this derivation, the vehicle and the vehicle movement is two-way. Okay, so in that case, the overtaking side distance would be d1 plus d2 plus d3. However, when only one way movement is there, then in that case d3 is absent, so we will be considering as d1 plus d2. Okay, so for the one way traffic, the overtaking side distance would be d1 plus d2, and for the two way traffic, this is d1 plus d2 plus d3. Okay, for 4 or more lanes, IRC suggests that it is not necessary to provide the usual overtaking side distance. However, the side distance on any highway should not be more than the stopping side distance. Okay, so what does the IRC recommend? That let us say if we have more than 4 lanes, then it is not necessary to provide the overtaking side distance, because there are sufficient number of lanes and the road user can overtake from any particular lane. Okay, however, it must be keep in mind that the highway that is the distance, the side distance should not be less than the stopping side distance. Okay, the minimum overtaking side distance is recommended as the 3 times of overtaking side distance, whereas the desirable is 5 times of overtaking side distance. Okay, whereas you need to also remember on the upgrade the side distance would be more, whereas on the downgrade the side distance would be less. However, you can go through the theories in the book to get it on the more clarity, because we are just focusing on the competitive approach. Okay, so let's go through a numerical so that you get more clarity. Okay, so let us say a question is there. Let us say we are calculating a question or the OSD. Okay, a data is given. The speed of overtaking vehicles is 70 kilometer per hour, and overtaken vehicle is 40 kilometer per hour. Okay, on a two-way traffic road. Okay, if the acceleration is given as 0.99 meter per second square, calculate calculate safe OSD. B point is minimum length of overtaking zone. Okay, so as we know, overtaking OSD, we are going into the very shortest approach, that is OSD is calculated as D1 plus D2 plus D3. What is D1? This is VB into T, this is VB into T plus 2S plus V into T. Okay, so what, let us first convert the values into meter per second. So VB is 40 kilometer per hour, that is the slow moving vehicle. So this is 40 into 5 by 18, this is 11.1 meter per second. And V is, that is 7 design speed, that is 70 kilometer per hour, then this is 70 into 5 by 18, this is 19.4 meter per second. Okay, acceleration is already given 0.99 meter per second square. Okay, so as we know T, what is T? That is the average reaction time, that is considered as 2 seconds in the case of overtaking side distance. Okay, so VB will be 11.1 into 2. Okay, this is the value for D1. Now D2, for the D2, what is value of VB? That is 11.1, and what is the value of T? So we need to calculate the T. T is calculated as 4S upon A. So for this relationship we also need to know the value of S. So how do we, S is calculated, that is the minimum spacing between the vehicles. So this is 0.7 VB plus 6 if V is given in the meter per second. However, if V is given in kilometer per hour, then this is 0.2 VB plus 6. So here we are calculating all the values in the meter per second. Okay, so we'll use this particular relationship. So what is the value of S? This is 0.7 into 11.1 plus 6, then this is 13.8 meter. Okay, now value of S is known, so let us calculate the T. T is equals to 4 into S upon A is 0.99 meter per second square. So you just need to calculate this particular relation and you will get the values as 7.47 seconds. So let's put the values over here. 7.47 second plus 2 into S. What is S? This is 13.8 meter. Okay, so this is D2. Now let's calculate D3. What is D3? V is the design speed, which we have already calculated over here as, sorry, design speed is 19.4 meter per second. So 19.4, and what is capital T? Capital T we have calculated as 7.47. So when we do the summation of all three values like A, B, C, when we do the summation of all three values, we will get to know the total overtaking side distance, and which is coming to be 277.6 meter. Let us say this is equivalent to 278 meter. Okay, so our first question is solved, that is calculate the safe overtaking side distance. Okay, our next question is calculate the minimum length of overtaking side distance. So we also know that minimum OSD, that is equal to 3 times of OSD. So 278 into 3 is our answer. This is 834 meter. Let us say if it has been asked to calculate the desirable overtaking side distance, then this would be equal to 5 times of OSD. Okay. So this is all about the side distance. In the next class we will be covering about the further horizontal alignment features. Thank you.